Renewable fuels, risks versus benefits. What is a renewable fuel? A renewable fuel is a form of energy that comes either directly or indirectly from the sun. Therefore, they will never run out. Fossil fuels. Currently here in the US, we rely mainly on fossil fuels such as coal and oil. These are finite resources. They will become more and more scarce, making them more expensive to obtain. Environmental impacts. What kind of damage do fossil fuels do to the environment? To release the energy in fossil fuels, they must be burned. The burning of these fuels releases sulfur, carbon dioxide, carbon monoxide, ozone-forming volatile organic compounds, and toxic air contaminants such as benzene, 1,3-butadiene, polycyclic organic matter, acetaldehyde, and formaldehyde. Clean energy. Examples of clean energy are hydroelectric power, geothermal energy, wind power, solar power, biomass, hydrogen, and nuclear energy. Hydroelectric power. Water is currently the leading renewable energy source used by utilities to generate power, according to the U.S. Department of Energy. Where running water is available, hydroelectric power can be utilized. Many of the best sites are already developed. The greatest advantage of this kind of power is that once the facilities are in place, it is very inexpensive to produce this source of power. Geothermal energy. Geothermal energy is generated from the heat within the earth, ranging from shallow ground to hot rock and water a few miles deep, to extreme depths with high temperature molten magma. This is clean, reliable, and homegrown. There are two different technologies currently in use: power plants and geothermal heat pumps. According to the U.S. Department of Energy, there are three types of power plants. Dry steam plants directly use geothermal steam to turn turbines. Flash steam plants pull deep pressure hot water into lower pressure tanks and use the resulting flash steam to turn turbines. Binary cycle plants pass moderately hot geothermal water by a secondary fluid with a much lower boiling point than water. This causes the secondary fluid to flash to vapor and drives the turbines. Wind power has been the fastest growing source of new electrical power generation for several years. According to the U.S. Energy Information Administration, or EIA, wind power increased 49.3% in 2006, 29.6% in 2007, and 60.7% in 2008. In 2009, generation from wind power increased 33.5% over 2008, bringing the share of total generation to 1.9%. Solar power. There are a variety of technologies. We have photovoltaic systems, solar hot water, and solar electricity. The photovoltaic effect, or PV effect, is the process of converting photons of light into electricity or voltage. Solar cells convert solar energy directly into electricity. The solar cells are similar to computer chips, but when in contact with sunlight, the semiconducting material allows the electrons to be knocked loose from their atoms, creating electricity. This is what we often see in calculators and watches. You can combine about 40 of these cells into modules, and then you can combine these modules and mount them into PV arrays, measuring several yards in length. These can be mounted at a fixed angle, or they can be put on a tracking device that follows the sun. Several can power a household, and hundreds can create a PV system to power a large electrical utility or for industrial applications. Solar hot water. Solar energy can be used to heat water for buildings and pools as well. This is a fairly simple process. Most solar water heaters are made up of two parts: a solar collector and a storage tank for the water. In the collector, There are usually small tubes with liquid inside. Active systems use pumps to move the liquid from the collector to the storage tank, and passive systems use gravity's natural tendency for water to circulate as it's heated. Pool systems are simple. The pool's pump is used to move the water through the collector, and the pool itself serves as a storage tank. Solar electricity. Most power plants currently use fossil fuels as a heat source, but concentrated solar energy can serve the same purpose. Parabolic trough technology uses long rectangular curved mirrors that are directed toward an oil-filled tube in the middle of the trough. As the concentrated solar energy heats the oil, the water steams, turning the turbine. Solar energy risks versus benefits. The benefits, of course, are the reduction of greenhouse gases and air pollution emissions that are caused from fossil fuels, and that it is an inexhaustible source of energy for any time in the foreseeable future. However, there are some risks. Very large areas of land would be necessary for commercial solar use. This poses a problem with the interference of natural sunlight, rainfall, and drainage, which could affect the wildlife. It could affect archaeology as well as current uses of these lands, such as grazing. The visual problem is that these solar arrays are very large geometric shapes. They're highly reflective. They could cause a disturbance in aesthetics as well as improper solar concentrations interfering with aircraft. Some technologies that use water could put a strain on demands in arid areas, and an accident could cause water pollution. The materials in photovoltaic panels can be hazardous if not properly disposed of, and the liquids, oils, and salts in the concentrate solar systems can also be hazardous if spills occur. Proper planning would be necessary to prevent such occurrences. Biomass. Biofuels are organic material from plants and animals. They're an attractive petroleum alternative. You can use agricultural and forestry residues, municipal solid waste, industrial waste, and terrestrial and aquatic crops grown solely for energy purposes. Many cars today have been engineered to run on E85, and most gasoline today includes E10 to reduce emissions for cleaner burning fuel. You may have heard of ethanol, which is primarily produced from corn and soybeans. They are currently working on a cellulosic crop development to use soil unsuitable for crops, so as not to put extra demands on the same soil we use for our food sources. According to the U.S. Department of Energy, studies show the corn ethanol we use now has 19% fewer greenhouse gas emissions compared to fossil fuels. But the cellulosic ethanol has the potential to reduce greenhouse gas emissions by up to 86%. Nuclear energy. Nuclear energy can either be fusion or fission. Fusion is the splitting of an atom, such as uranium. Fission is the combining of an atom. According to the EIA, there are currently 104 commercial nuclear reactors at 65 nuclear power plants in 31 states. Japan depended heavily on their nuclear energy source, but the recent problem involving the tsunami made me wonder if these sites are as safe as they try and make them sound. Hydrogen. Hydrogen is the simplest element. It contains one proton and one electron. It is the most plentiful element on Earth, but it's never found alone. It's always combined, as in water and organic hydrocarbons. Hydrogen can be used in many ways, but currently the government is focusing on hydrogen-powered vehicles. The biggest problem is the transportation of hydrogen. It can be transported in three forms: compressed, liquid, and combined. combine with other molecules such as water or hydrocarbons, but this then has to be processed. Once the hydrogen is isolated, it can be compressed. Compressed hydrogen takes up about 3 times more volume for the same energy as gasoline. Ideally, a carbon fiber tank would be used, but these are very expensive. An accident with a tank of hydrogen would be equivalent to an explosion from dynamite. Liquefying hydrogen would be the best transportation method because it could be carried in a lightweight tank. However, the problem is that it is still highly explosive, and during the liquefaction process, about 30% of the energy is lost. The most reasonable form of hydrogen energy is the fuel cell. NASA has been using them in their space shuttles for years. A fuel cell is similar to a battery, except as long as the fuel source is there, in this case hydrogen, the battery never runs out or dies. They are energy efficient, clean, and fuel flexible, meaning hydrogen is not the only fuel that will run a fuel cell. The U.S. Department of Energy states, "The Office of Energy Efficiency and Renewable Energy is working to lower the cost and improve the durability of PEM fuel cells. Currently, research and development activities focus on improving electrocatalysts, membranes, both for ambient and high temperature applications, and bipolar plate materials." I will cover fuel cells in more detail on the next slide. There are 2 main types of fuel cells: a proton exchange membrane fuel cell, or PEM cell, or a solid oxide fuel cell. Slide 20 shows the PEM fuel cell. On slide 21, you'll see a solid oxide fuel cell. As I said before, the fuel cell is like a battery that always runs. It's made up of 3 parts: the electrolyte, the anode, and the cathode. For the SOFC, the electrolyte is made up of a ceramic material. Unlike the other types of fuel cells which use precious metals, corrosive acids, or difficult to contain molten materials. An electrical chemical reaction converts fuel and air into electricity without combustion. This is a high temperature fuel cell. At a high temperature, the warmed air enters the cathode and steam mixes with fuel to create reformed fuel. This enters on the anode side. The chemical reaction begins in the fuel cell, and as the reformed fuel crosses the anode, it attracts oxygen ions from the cathode. These combine to produce electricity, water, and a small amount of carbon dioxide. The water gets recycled to produce the steam generated that's needed to reform the fuel cell. The process also generates the heat required by the fuel cell. As long as there's fuel, water, and heat, it will continue to create clean, renewable, and affordable energy.